students, today we shall start with the next chapter, that is pointers. So we shall first see the introduction to pointers. A pointer is a derived data type in C. So this is the most important thing we should remember, that pointer is a derived data type. We have fundamental data types, we have derived data types, and we have user defined data types. Fundamental data types are, which we have studied earlier, that are character, integer, float, double, etc. Using these fundamental data types, we create new type of data type, and that is known as derived data type. It is built from one of the fundamental data types available in C. Pointers contain memory addresses as their values. Pointers are same like variables which we have used earlier, but in this case these pointers are not going to store some values, but they are going to store memory addresses. Since these memory addresses are the locations in the computer memory where program instructions and data are stored, pointers can be used to access and manipulate data stored in the memory. Okay. Next we shall see the benefits of pointers. Pointers are used frequently in C as they offer a number of benefits to the programmers. They include, first is, pointers are more efficient in handling arrays and data tables. Okay, so pointers makes us operate quickly and effectively for handling arrays and data tables. We have seen arrays previously, and the two-dimensional arrays are data tables. So if we want to operate quickly and effectively arrays and data tables, it is better we use pointers. So this is the first benefit. Second, pointers can be used to return multiple values from a function through function arguments. We are going to see our next chapter of functions. At that time we shall discuss this point. Third benefit, pointers permit references to function and thereby facilitating passing of function as arguments to other functions. This point also we shall cover in our next chapter of functions. Next benefit, the use of pointer arrays to character strings results in saving of data storage space in memory. More benefits, pointers allow C to support dynamic memory management. In C we can dynamically attain or allocate memory when we are running a program. At that time we are going to use the concept of pointers. So pointers allow C to support dynamic memory management. Next benefit, pointers reduce length and complexity of program. When we use pointers in our programs, it reduces our length of program and also the complexity of the programs. They increase the execution speed and thus reduce the program execution time. Since pointers uses the memory addresses, the execution speed increases because the compiler will directly go to the memory address. Hence the program execution time will also get reduced. So these are some of the benefits of using pointers. A pointer is a concept used with a computer's memory. The memory of a computer is represented as an array of consecutive memory locations which have a unique identification number. This number is known as the address of that particular memory location. These addresses are used to easily locate the variable and find out their values. So this was an introduction of pointers. Next we are going to see understanding pointers. The computer's memory is a sequential collection of storage cell. Okay, so we can see computer as a sequential collection of storage cells, commonly known as byte, has a number called address associated with it. The addresses are numbered consecutively starting from 0. The last address depends on the memory size. So I hope you know how the computer's memory is organized in the fundamentals of computers. Each cell is known as a byte, which stores the binary digit, and each byte has a address which is known as a memory address. The first byte always address starts with 0. We shall see in the diagram over here. This is the consecutive memory location. Each memory, this is a storage cell which is known as a byte. So here you can see this is the first byte, second byte, third byte, and so on. Each byte will have a memory address starting from 0, and the last byte address will depend on the memory size. In this case it may be 65,535. Okay. Whenever we declare a variable, the system allocates somewhere in the memory an appropriate location to hold the value of the variable. So this memory will be allocated to variables, instructions, and data. Some bytes may be free, some bytes may be allocated. Whenever we declare a variable, which byte is free over here will be allocated by the system, and the location to that particular byte will be given some address, and the value will be stored at that particular byte. Okay. Next we'll see an example. Here I have given an example. Integer quantity is equal to 179. So when we declare this variable quantity, the system will allocate a memory to this variable C, and this memory address will be given to the compiler. This statement instructs the system to find a location for the integer variable quantity and puts the value 179 in that location. So here I can show you graphically. Quantity is the name of the variable. This variable stores the value 179, and this quantity will be allocated some memory space. That memory space will be having some address. In this example, the address is 5000. So the name of the variable is quantity, the value stored is 179, and the address of the memory location is 5000. During execution of the program, the system always associates the name quantity with the address 5000. This is similar to having a house number as well as a house name. So this is the house, this has the house number, and this is the house name. We may have access to the value 179 by using either the name quantity or the address 5000. Since memory addresses are numbers, they can be assigned to some variables that can be stored in the memory like any other variable. Such variables that hold memory addresses are called pointer variables. Okay, so suppose if I store this 5000 value in some variable, that variable will be known as a pointer variable. A pointer variable is a variable that contains an address, which is a location of another variable in memory. Since a pointer is a variable, its value is also stored in the memory in another location. Suppose we assign the address of quantity to a variable p. So in this case, quantity is the name of the variable. This variable stores the value 179 and the memory allocated for this address is at 5000. Okay, I have created one more variable whose name is p and it stores the memory address of 179. So the value of p is 5000, which is nothing but the address of quantity. When we are storing this some value of p, this will also require a memory. So when it is stored in the memory, it will also have an address. So the address for p is 5048. So in this case we can say now that p points to 179. Remember, this 5000 is not a normal regular integer. It is an address. Whose address? Address of quantity. So p stores the address of quantity. That is why we say that p is a pointer variable. Since the value of the variable p is the address of the variable quantity, we may access the value of quantity by using the value of p, and therefore we say that variable p points to the variable quantity. Therefore p gets the name pointer. Okay, so p stores the address of quantity, so we say that p points to quantity. We can access this value 179 with the help of the variable name and also with the help of the pointer variable. How to access this we are going to see in our next lectures. So for today you understood what is a variable and what is a pointer variable. A pointer variable is a variable that contains an address of another variable. Okay, thank you.